Good day, mates. Good day, sir. Good day, everyone. We are the Group 6. I am the Cadet Topana Joshua, and here are my teammates, the Cadet Ortega Solo Jr., the Cadet Polican Warren, and the Cadet Pepito Julius Lester to present and discuss the Great Circle Sailing and the course of Mtec 101 in the period final week 2. So our topic for today is Great Circle Sailing. So here is the given problem or situation. A vessel from latitude 35 degrees 27 minutes north, longitude 139 degrees 39 minutes east, sailed to latitude 37 degrees 48 minutes north, longitude 152 degrees 20 minutes west. So we're going to find the great circle distance, difference of latitude, difference of longitude, initial course angle, initial course true, final course angle, and final course true. So here are the following data or values that we're going to get today. So on a lighter note, the following solutions were first-hand solved and were evaluated by the cadets before it was encoded for your convenience. Thank you. So our solution starts here with number 1, difference of latitude. So let us have the 35 degrees 27 minutes north as our latitude 1, 37 degrees 48 minutes north as our latitude 2. So according to the rules, when the two latitude have like names, it's either both north or both south, subtract the lesser latitude from the greater. So in other case, when the latitude have unlike names, add the two latitude. Since we have both latitudes north, we're going to subtract it. So then we'll have 02 degrees 21 minutes north. In naming the direction or the latitude, in our case, since latitude 2 is at a higher latitude than latitude 1, it presumes that the ship is going north. So the final answer for the difference of latitude is 2 degrees and 21 minutes north. So for the difference of longitude, so let's have 139 degrees 39 minutes east as our longitude 1. 122 degrees 20 minutes west is our longitude 2. Again, according to the rules, when both the longitude 1 and longitude 2 have the same names, subtract the lesser longitude from the greater longitude and name it according to the direction. But in our case, since both longitudes have different names, we're going to add the two values and name the DLO the same as longitude 2. So the sum would be 261 degrees 59 minutes west, and we're going to name it west because it is referred to longitude 2. In this case, if the sum is more than 180 degrees, subtract it from 360 degrees and name the tilde opposite from the longitude 2. So it is because it exceeds the limit of 180 degrees. Then we're going to have the total of 098 degrees 01 minutes east. So it is named east because according to the rules, you should name the longitude, final longitude, opposite to the longitude 2. So our final difference of longitude would be 098 degrees 1 minutes east. Let us have the next reporter for their parts. Thank you.
So thank you for that, Mr. Oponda. So after getting the D-lat and the D-low, we need to get next the great circle distance. So we have this formula, the cosine GCD, open parenthesis, cos D long times cosine latitude 1 times cosine latitude 2, close parenthesis, plus minus sine latitude 1 times sine latitude 2. So next, we need to substitute it first. So our D long would be cosine 098 degrees 01 minute times cosine latitude 1, which is 35 degrees 27 minute, times cosine latitude 2, which is 37 degrees 48 minute. So plus, it is plus because the D-lat's name is the same. So like names is positive. So next is sine latitude 1 is equals to 35 degrees 27 minute times sine 37 degrees 48 minutes. So next, we need to multiply this first. So cosine, cos D long, cos latitude 1 and cos latitude 2. So after that, we will get this answer from the substitutions. negative 0.977 plus 0.35548 from different equations. So since cosine GCG, we need to reverse it to cosine, reverse cosine. So reverse cosine 0.2657 is equals to 74 degrees 35.5 minutes. So since we are needed to find the distance, we need to times 60 so that our units would be nautical miles. So 74 degrees 35.5 minutes times 60 is equals to 4,475.5 nautical miles. So that would be our great circle direction. So thank you. So next.
Thank you for that, Cadet Ortega. So after getting the D-low and D-lat, we can now get the initial course angle and initial course through. So the formula for that is the cosine initial course angle is equals to sine latitude 2 minus the product of cosine great circle distance times sine latitude 1 over sine great circle distance times cosine latitude 1. So the first step is substituting the values. So sine 37 degrees 48 minutes minus the product of cosine 74 degrees 35.5 minutes times sine 35 degrees 27 minutes over sine 74 degrees 35.5 minutes times cosine 35 degrees 27 minutes. So after calculating the operations on the formula, we can get 0.61291 minus 0.15410 over 0.96406 times 0.81462. So the answer for that is 0.45881 divided by 0.78534. So now we can get the value for the cotangent. So cotangent 0.58422 is equals to 54.25209. So in order to get the initial course angle, we shall turn it into degree. So turning into degrees is by pressing shift degree symbol equals on the calculator. So the answer for that would be initial course angle is equals to north 54 degrees 15.1 minutes east, and the initial course through, which is 54.3 degrees through. So next will be reported by Warren Paulican.
Thank you for that, Decade Tepito. So after getting the initial course angle, we will now find the course angle and the final course through. So in getting the final course angle, we will use the formula cos final course angle equals sine latitude 1 minus open parenthesis cos great circle distance times sine latitude 2 close parenthesis divided by sine great circle distance times cos latitude 2. Next, we should simply substitute the following values. Sine latitude 1 or 35 degrees 27 minutes minus open parenthesis cos GCD or 74 degrees 35.5 minutes times sine latitude 2, which is 37 degrees and 48 minutes close parenthesis divided by sine GCD or great circle distance, which is 74 degrees and 35.5 minutes times cos latitude 2, which is 37 degrees and 48 minutes. Next, after calculating the following operation, we will now get the answer, which is 0.57999 minus 0.16825 divided by 0.96406 times 0.79016. So next, the answer is 0.41741 divided by 0.76176. So after dividing it using the calculator, we will now get the answer. At this time, we will transpose. So to get the cotangent or cos -1, open parenthesis 0.5476, close parenthesis, and now we will get the answer, which is 56.79748. So in converting that into degrees, you should, sorry sir. So in converting that into degrees, you should just simply press shift degree symbol in your calculator, then press equals. So now we will get south 56 degrees 47.8 minutes west. Next, we'll find the final course through. So the value falls into the southwest direction, so it falls in the third quadrant. So we just simply subtract the final course angle by 180 degrees. So 180 degrees minus 56 degrees and 47.8 minutes. So now we will get the final true course or final course true, which is 123.2 degrees true. And that would be all for the report of Group 6. I hope that you learned a lot from our report. Thank you for listening.